Okay, today we're going to be talking about the division properties, and we're really going to dive into the first two division properties, and tomorrow we'll cover the third one. Um, you're going to see some similarities between this and the multiplication properties, so hopefully you can use those similarities to help you remember both. Okay, when we have a quotient of powers property, and the quotient tells us division, so basically what it's saying is when you have an exponent, or like 6 to the 7th, being divided by another exponent, or 6 to the 4th, they both have to have the same bases, then what we're going to end up doing is actually subtracting those. So if you remember back to the multiplication side of it, it was something like if you have 6 to the 7th times 6 to the 4th, and the rule said if the bases were the same and it was multiplication, then all you had to do is take 6 to the 7 plus 4, and you got 6 to the 11th. Now we're into the division side, and it's saying if it's divided by, or if they're a fraction, then what you're going to end up doing is subtracting it to get 6 to the third. So notice that multiplication is the opposite of division, and as a result, we're going to say that and do the opposite when we're computing them, because the opposite of addition, instead of adding, we're going to subtract. So let's try some examples. First example is 3 to the 8th power over 3 to the 2nd power. Because the bases are the same, they're both 3, then we can keep the same base and simply subtract the exponents, and we get 3 to the 6th power. Our next example has variables. We have x to the 5th over x to the 5th. Again, x to the 5th, or x is the same base on both, so we can take 5 minus 5, and we get x to the 0. And now we learned a couple days ago that anything to the 0 power then is 1. Which makes sense, because remember, whenever you have a fraction over a fraction, 3 divided by 3, we always get 1. Same thing here. The same number, when there's the same number top and bottom, we get 1. And then our final example involves exponents and a little bit of our multiplication properties. So let's look at whenever you have a product or two different bases. First, we're going to have to recall our multiplication property that says the fourth distributes to both. Once we distribute it, then we're going to get the same thing on top, but on bottom you're going to get a to the fourth and b to the fourth. Now we can take this and simplify each one. And those are some pretty bad circles. I'm just going to circle one at a time. But let's go with a to the 5th and a to the 4th. Because the base is the same, we can do a to the 5th minus 4th, and we just get a. And then now we can simplify the b's because they're the same bases. We have b to the 9 minus 4, and we get b to the 5th. And that would be our answer. Okay, the second rule is going to say when you have a fraction or a number divided by a number, you don't even have to have the same bases. But if that entire thing is being raised to an exponent, that exponent then distributes to both. Okay, this is also similar to our multiplication rule when we had two products. With the two bases, this would distribute to both. This is going to be similar to that. The exponent is going to be distributing to both. So we get x to the 4th, y to the 4th here when it was multiplication. Now we're in our division rules, which means we're going to get 3 to the 3rd, 4 to the 3rd, and we can actually take that one step further and simplify it down to get 27 over 64, because 3 to the 3rd power is 27, and 4 to the 3rd power is 64. So if we wanted to try an example here, we're going to, again, distribute this to both. And so what originally was there is 2 to the 3rd power. And now it's going to be taken to the 2nd power because this is being distributed. And then we're going to have 3 to the 2nd power was the original. And that's also going to be taken to the 2nd power. We use our rules of multiplication that says if it's a power of a power, we multiply the exponents. So 3 times 2 gives us 6, and 2 times 2 gives us 4. We can then take it one step further and say 2 to the 6th power is 64, and 3 to the 4th power is 81. This next example really combines a lot of our rules. The first rule it's going to do is um, what we just learned is how this 3 distributes to everything. Okay? And so you're going to get a to the 3rd power, and it now is back to the 3rd power. B to the 3rd power. Then a to the 2nd power to the 3rd, and then it used to be b to the 2nd power, and now that's going to be raised to the 3rd power. We can then simplify using our powers of powers. A to the 3rd, because it's a power of power, we multiply the exponents, so we get a to the 9th, because 3 times 3 is 9. B to the 3rd stays the same. And then we have a power of power here. 2 times 3 gives us 6. And then 2 times 3 here would also give us 6. And so now we can use the first division rule that said if the bases are the same, all you have to do is subtract them. So you get a to the 9 minus 6, which is simply a to the 3rd. And we can simplify this one. B to the 3 minus 6, which is b to the negative 3rd. And now, if we use yesterday's rule, we have to simplify this one. This is the only one that we have a problem with because it's negative. How we're going to fix it is moving it down. So we're actually going to get a to the 3rd over b to the 3rd. I really like this problem because it really challenges us to recall all of our properties in one problem. Okay, I hope that helped you with the first 2 rules of division, and we'll see you tomorrow.